Hello, everyone. Happy Tuesday. Today we're going to be talking about natural disruptions. So this is the first day of natural disruptions, and we're going to be focusing in on the geologic timescale as well as climate change. So climate change throughout history has always made things worse, including right now. And our geologic timescale is going to be in billions of years. And yes, this month has felt like March of this year felt like a billion years. All right, so a brief history of the Earth. So Earth is about 4.6 billion years old. Life began at least 3.7 billion years ago. New evidence is suggesting closer to like 4.1 billion, but it's still not 100% set in stone. So in terms of our kind of time scale, we're not even a blink of an eye on Earth's time scale. So if you look at this here, this is kind of like the big things that have happened in Earth's history. That little dot, that's us. So we've only been around for about 315,000 years, could be earlier, which is 0.0068% of all the time on Earth. So we have been here less than a blink of an eye. So because Earth is so old, we have what's called the geologic timescale, and this is going to divide the history of Earth into kind of different categories. So the largest category are eons. So these can be like billions of years long. So there are 4 different eons. We have the Hadean, the Archean, the Proterozoic, and the Phanerozoic. We are currently in the Phanerozoic. We are here. These 3 eons here, you'll see they don't have any eras or periods or epochs, which are kind of the other little sections of our geologic timescale. So not a lot really happened. Life started big, I guess, but not really anything that we can study because it was so long ago. So the 3 eons before our eon are kind of like, they don't really need any little broken down bits. So in only our eon, the Phanerozoic, we have these things called eras. And those are going to separate out large chunks of time, and we can talk about what happens in each era. And then within each era, we also have epochs. And these are going to separate time within each era. So this is our era, and then here is an epoch. For our current era, we do have periods as well because we know a lot more about our time, the Cenozoic, than we do about later times. But that's kind of how we do the geologic time scale. Eons are the biggest, then eras, then epochs. So thinking about disruptions, the geologic timescale obviously is over large periods of time. And just like large periods of time have, occurred on Earth, so have disruptions. So disruptions can take place. There's a couple different terms we can use to describe them: periodic, episodic, and random. So periodic is going to be happening at regular intervals over time. So we can really predict those. So that's going to be nothing quite as big as like a volcano, but like the tides. We know when the tides come in, we know when they go out. And it happens on the same specific schedule. Episodic means happening at irregular intervals. So in terms of natural disruptions, this is going to be things like volcanic explosions. They happen at irregular intervals. There's not really a great way to predict it. And then there's random. Can't predict when it's going to happen. This is going to be like a meteor that strikes the Earth, which, remember, helped kill off the dinosaurs. So all of these different things can be used to describe different disruptions. And disruptions can sometimes last for like millions of years. So there was a time when like Earth was just like a fiery ball, and it was just splurting lava for like years, like millions of years. So climate change is not just for humans. So Earth's climate has drastically changed over its 4.6 billion year history. There are natural causes of climate change. Unfortunately, right now we are causing climate change. But there are natural causes. It's happened all the time. So the four biggies are going to be changes in greenhouse gases in the atmosphere. So there are some natural things that can cause that to happen. That's what we're doing right now is we're changing the amount of greenhouse gases in the atmosphere, but that can also happen naturally. Plate tectonics. So, um, Gondwana, Pangea, all of the different places where our continents used to be, that's going to change. That's going to change the climate depending on where they are. Oceanic currents. So we'll talk about this more when we get to like weather, but ocean currents are really going to affect the climate of the different land masses. And also volcanic eruptions. So volcanoes, one, spurt out carbon dioxide, which is going to add greenhouse gases into the atmosphere. But two, if they're big enough, they're going to cover the entire world with ash. And that is also going to change the climate as well. We know a lot about the past based on ice cores. So we can look at ice cores and all those bubbles trapped in the ice cores and measure how much methane, CO2, and kind of get an estimate of the temperature, which is really cool. So that's how we kind of know some of the stuff about Earth's past history is the ice core record. Okay, so one of my favorite examples of extreme climate change on Earth is Snowball Earth. So remember, greenhouse gases trap the heat from the sun, warming up the Earth. If there's less greenhouse gases, there's going to be cooler Earth. So about 2.1 billion years ago, the Huronian glaciation took place, and it was actually caused by the evolution of photosynthesizers. So remember, photosynthesizers take in CO2, which up until that point hadn't happened. So our atmosphere was full of CO2. Photosynthesizers evolved, and all of a sudden, they're going to take in that CO2. The other crazy thing is that they pump out oxygen, which also hadn't happened. So before this, there was really not a lot of oxygen in our atmosphere. Actually, like none. And the oxygen reacts with methane and actually takes the methane out. And methane is also a powerful greenhouse gas. So the entire Earth froze. In that picture, that entire Earth, except for this maybe one small band around the equator. Pretty crazy. So that was the Huronian glaciation, but even more fun. Right before the glaciation took place, there was a lot of oxygen in the atmosphere, and there was a lot of iron in our ocean. So at this point, it was an oceanic world. And the iron had never really reacted with oxygen before because there was no oxygen. And we know that when iron and oxygen get together, it forms rust. So our oceans were literally blood red a while before we turned into a big snowball. And we know that because of rocks that look like this. So can you imagine blood red oceans? Not so. Okay. Also, fun thing to talk about, the PETM. So this is going to be more greenhouse gases the hotter the Earth. So this was only 56 million years ago, which again, post-dinos. I know it's kind of confusing. But this is the Paleo-Eocene thermal maximum, or the PETM. And it's due, basically, all of a sudden, there was a bunch of carbon dioxide and a bunch of methane released into the atmosphere all at once. There's a lot of theories like forest fires, maybe coal was pushed up to the surface and a volcano hit it and it just caught all this coal on fire. But at some point in those ice cores that we're sampling, we just see a spike in CO2 and methane. And it's not, like I said, sure really why. But because of this, tropical rainforests extended over much of the globe. Our poles, the North and South Pole, were forests. Like, no ice, literally no ice. The water at the equator was around 36 degrees Celsius, almost 100 degrees Fahrenheit. And this warming took place over like 10,000 years, and our average temperature increased like 8 degrees Celsius, which is insane. So it was the fastest warming event ever. Unfortunately, based on our ice core samples, we were getting somewhere close to the amount of carbon dioxide that was released before the PETM. And so are we going to go back to the PETM? Maybe in another 100 years if we haven't done anything about climate change. And are we trying to beat the record? It seems like it. All right, so interactive notebook time. So there are 2 videos from PBS Eons, and if you're a science nerd like me, you will love PBS Eons. They have so many cool videos. I would for sure check out their channel. They have some really cool videos. You're going to be watching 2 today and just answering some questions in your interactive notebook. All right, if you have any questions, remember office hours 2 to 2:20, and you can find the link in your Google Calendar. I will see you guys tomorrow. Bye.